Hello everybody, this is Brian from the Delta College Planetarium, and I have a question for you. How long is a day? I can hear it already, the mad rush to the comments to tell me a day is 24 hours, of course. And yep, that's it. Great job. Video over. Or is it? A day isn't just something arbitrarily chosen by humans, like a yard or whatever. It actually reflects something about our physical reality, or whatever. So what is a day and how do we measure it? A day is one full rotation of a planet, a complete cycle of daytime and nighttime. Quick note, every time I use the word day during this program, this is what I mean. I'll use the word daytime to refer to the portion of the day when the sun is in the sky. How do you measure how long it takes the whole Earth to rotate? Just like trying to make any kind of measurement, we need some fixed point to start tracking this cycle, an origin point. The sun is the big, bright, obvious thing to use. Maybe we can measure the time from one sunrise to the next, but we run into a problem. The Earth's axis is tilted, and as a consequence, the proportion of daytime to nighttime changes from day to day. As we head into the summer in Michigan, the time from sunrise to sunrise is shortening as nighttime disappears. We'd be shortchanging the day by a few minutes if we measured it this way. The problem happens in reverse when we're moving away from the summer solstice. Instead, we could measure the time between when the sun reaches its highest point and when it returns there. The sun will reach its highest point when our part of the Earth is pointed directly at the sun. We'll call this a solar day because it's based on the sun's location. This is much better than measuring sunrises, and we measure the time between the highest points to be just about 24 hours. But it's not perfect. Earth orbits the sun in an ellipse, not a perfect circle. The distance between the two varies throughout the year, and this distance has a slight effect on the time it takes the sun to return to its highest point in the sky. A solar day can be about 30 seconds longer or shorter than 24 hours, depending on the time of year. But that's still a really good and consistent measurement, and if we average out many decades of days, we find that the mean solar day is very nearly 24 hours. Something else tricky is going on too. Every day, the Earth moves a little bit more in its orbit around the sun. Earth has to turn a little bit more each day to point at the sun again. You can see this effect on the ground as the stars appearing to change their position slowly over many nights. The stars set earlier each night as Earth proceeds in its orbit. How long does it take one of these stars to return to its highest point? Or, to put it another way, how long does it take the Earth to point in the same direction relative to the distant stars? That length of time is about 23 hours and 56 minutes. We'll call this a sidereal day, from the Latin for star. A sidereal day is just about 4 minutes less than a solar day. Every day on Earth, these 2 days are happening simultaneously. So which one, a solar or a sidereal day, is the right one? Well, they both are. For the most part, people care about when the sun is up, so we default to using solar days. But sidereal days are really important for astronomers because we like to look at the stars. If telescopes only took into account the time based on the solar day, the stars would slowly drift in our instruments. What about days on other planets? How long are those? For the other terrestrial planets in the solar system, we can use the same ideas to measure a day. A solar day on Mars is about 40 minutes longer than on Earth. Venus is strange because it slowly rotates backwards. A sidereal day on Venus is longer than the time it takes Venus to orbit the Sun. What about Jupiter? We can't see the surface of the gas giant. It probably doesn't even have one. We could try measuring the time it takes some feature in Jupiter's atmosphere to move around the planet, but the clouds on Jupiter are really fluid and they travel at different speeds. Clouds near Jupiter's equator travel faster than the clouds near the poles. For Jupiter and the other gas giants, we have to use another feature of planets to measure a day, something that is invisible or reveals something about a planet deep down beneath its clouds: the planet's magnetic field. Just like Earth, Jupiter's intense magnetic field is tilted slightly from its axis of rotation. That angle gives us a fixed frame of reference to measure the day on Jupiter. It takes Jupiter's magnetic field 9 hours, 55 minutes to rotate once. This is how we define a day on Jupiter. The same strategy can be applied to Neptune and Uranus, but Saturn stubbornly refuses to cooperate. Just like Jupiter, Saturn has a strong magnetic field, but unlike all of the other planets in the solar system, Saturn's magnetic field is very closely aligned with its axis of rotation, making it very difficult to measure a day. For a long time, planetary scientists had narrowed down a day on Saturn to be between 10.6 and 10.8 hours. That may sound pretty good until you realize that it's a difference of about 12 minutes. On Earth, we know the length of a day to small fractions of a second, but on Saturn, we can do no better than the nearest 12 minutes? We need a different strategy. As the second largest planet in the solar system, Saturn has a strong gravitational field, and like all planets, Saturn is oscillating. There are waves traveling through it all the time. It's literally ringing like a bell. These oscillations create places inside Saturn that are a little denser than on average, and the gravity of these dense spots pulls a little more strongly. But unlike other planets, Saturn is surrounded by a system of huge, thin, and bright rings. The particles in the rings respond to that uneven gravity, building waves. This photo of Saturn's sea ring was taken when the sun's light was very nearly parallel to the ring plane. You can see these waves as a series of brighter rings. They're brighter because they are elevated above the ring plane and catching the sunlight. The sea ring's shape is like corrugated cardboard. By tracking the motion of those waves through the rings, in 2019, scientists were finally able to measure the rotation of Saturn's gravity. A day on Saturn is 10 hours, 33 minutes, even shorter than the estimates based on its magnetic field. This is one of the coolest things about astronomy to me. Examining this tiny idea that you take for granted, like how long a day is, can take you on this journey billions of miles across the solar system to study the slight pull of gravity on the fine particles of Saturn's rings. Even the simple questions lead to big ideas.